Huddersfield in Yorkshire. I'm on at the top of a hillside and I'm absolutely freezing. I've been told I've got to find out about fire, which is just as well because I could do with some warming up, and I'm hoping that they've got I must have jumped a mile. Well, I suppose that was fire, all right.
Quite a surprise, Helen. Yes, quite a surprise, that's right.
It wasn't just an explosion from
No, we thought
nowhere.
we'd surprise you with that. OK, Helen, let me introduce myself. My name's Barry Cook. I'm the chief chemist here, and this is a site where fireworks are made. Your challenge is to learn about fire, and to begin your challenge, if you'll follow me now down to the laboratory, we can make a start.
OK. My heart is beating for that.
It'd be that long.
And what Helen doesn't know is that her challenge will be to set up a firework display to be watched by 6,000 people.
So cruel. Hello.
Hi.
Helen, this is Michelle, who's going to teach you how we make fireworks.
Michelle,
Hi. Pleased to meet you.
You're going to put me to work, are you?
Yes, I am.
OK.
The first thing we need to get anything to burn is a fuel. So I've chosen this fuel here. It's fine black powder.
And what's that?
Right then, that's charcoal. Now you're probably not familiar with it in that form, but you'll be more familiar with it in this form here.
Oh, the stuff you get on barbecues.
That's
yes,
it,
huge
as you can
chunks of
see.
it.
All we've done is we've broken that down into little pieces, which gives us that fine black powder. So what I'd like you to do now is to try and light that, please.
Like this?
Yes. We'll take this over to the fume cupboard over here.
I've never heard of that before. What's a fume cupboard?
It's a safe cupboard where we can set fire to things, and any smoke we make, there's a fan in it, and it pulls all the smoke outside the building to make it safe. Right then, so we've got some matches.
Right.
And you can put some safety goggles on as well to protect your eyes.
Oh, so is it pretty dangerous then?
It can be dangerous sometimes.
OK, so here goes. Let's take the match to the charcoal. Oh, OK, that one went out. Let me try it again. Oh. I can't understand what I'm doing wrong.
When a fuel catches fire, a flame is formed. The fuel in this match is the wood it's made from. Other materials can be fuels as well. The blue liquid in this lamp is called paraffin. Heat from a match flame will make the paraffin catch fire. The paraffin moves up the wick to replace what is burnt. A gas can be a fuel as well. The blue bottle contains a gas called butane. With the tap open, the gas moves through the pipe to a burner. The fuel in this barbecue is charcoal. The glow is from the charcoal burning, but to get it to burn like this, you've got to heat it for some time. Earlier, a firelighter was used to set the charcoal alight. As the heat built up, the fire was established. This electronic thermometer shows the temperature inside the bowl is over 500 degrees Celsius. By closing these holes, the speed at which the charcoal burns slows down. If left like this, the fire would eventually go out. We can see from the thermometer that the heat is still there. It's the air around the fire that's been reduced. So a fire needs air as well as heat and fuel. Air is a mixture of gases, and the important one for a fire is oxygen. By opening the holes, more air and so more oxygen is let in, making the fire burn hotter and faster again. So for anything to burn, we need three things: a fuel, heat, and the oxygen in the air.
Oh, this is better. I'm getting a red glow now, especially when I fan it with my hands.
The oxygen in the air is what's helping it to burn. So as you're fanning it, you're adding oxygen, which is making it burn much hotter and much faster. So for a firework, we need to speed this up so it all happens very fast. Right then,
To do this, a chemical called an oxidant is mixed with the fuel.
When you burn an oxidant, it releases oxygen, which helps the fuel to burn in the firework.
The amount of oxidant used affects the speed at which the fuel burns. To show this, Helen and Michelle make two mixtures. The first with an equal amount of oxidant and fuel. The second with the same amount of fuel but with twice as much oxidant.
Why are you mixing it on this paper?
We don't want anything that might cause a spark with the fuel and the oxidant.
Could this catch alight then?
It could do, yes. But now we've got quite a dangerous mix, so what we're going to do is take it down to our test site to test it.
Hello? Hello.
Right, this is Debbie. Debbie, this is Helen. She's going to do the testing for us.
Oh, good.
So there's the first mix.
Right, I'll test this for you then. All I'm going to do is just put some of your mixture, and I'm going to light it. See how it burns.
Right then, we better stand this back out of the way.
At last, I finally got a flame. It's still quite slow though, why is that?
That's because of the amount of oxidant that's in it. Obviously, with more oxidant, it will burn faster.
Aha, good. I'm looking forward to seeing what this does
Right
then.
In slow motion, we can see the fuel burns along the trough much faster than before.
Right then. Now the fuel and the oxidant burnt without much colour, very exciting. So now we need to add a third chemical. This is added to give a colour to the firework.
So that looks incredible. It's so bright. When it burns, is it going to be that colour?
No, that in fact is going to be blue.
Oh.
That will give a green flame, and this powder here would give a red flame.
You just
you want
can't
to-
guess from looking at it.
Right. So if you'd like to choose one of the chemicals and add it to the fuel and the oxidant mix, and then we'll see what colour we get.
Yes, I'd love to get a red. Well, I've mixed in the colour. How are we going to test it?
Well, what we've done, we've taken your mixers and filled these little tubes.
Oh,
Would you like to test them now? and see
yes,
what
I'd
they're
love
like?
to. Okay, here goes. I'm going to stand way back. Whoa!
Let's go.
Stay clear. That was a lot more dramatic than I thought. Green, blue, white, red, and what's that, orange or yellow at the
Yellow.
end? Yellow. It's a lot more definite now, they're beautiful.
You've done well.
How hot is a firework? The temperature of ice is 0 degrees Celsius. A warm day is 20 degrees Celsius. A hot cup of coffee is 70 degrees Celsius. Boiling water, 100 degrees Celsius. A firework? Those brilliant points of light are burning at 2,000 degrees Celsius or more. Such high temperatures are dangerous, so time is needed to get away from a firework once it's lit.
When lighting a firework, we use this blue touch paper. This burns for about 8 seconds and allows us to move away to a safe place while the firework is burning. For our larger fireworks, we use this fuse wire. The blue wire is the slowest, then the red, and then the yellow, which is the fastest.
These fuses are used in large displays to control the times between firing the fireworks.
Another type of fuse which we use is called piped match, and I'll show you how this burns. Right. I'll just lie this along here, like that. The fuse which we use is actually cotton string, which has been coated with gunpowder, and when we light it, It burns for about 3 centimetres a second. Once the flame goes inside this tube, it becomes a lot hotter, and this increases the speed of the burn.
Altering the speed a fire burns at is what makes fireworks both exciting and dangerous. When fireworks are lit, we look forward not only to their colours, but also to their sounds and movement. These effects are achieved by the way the chemicals are packed into tubes and controlling the speed, direction and time they burn. When using fireworks, it's important to be safe and to follow the instructions printed on them. For example, sparklers should be lit one at a time. If several are lit at once, a dramatic change occurs. The flame is hotter and the sparklers burn faster. You must never try this. We're using a dummy hand. If a person had been holding this bundle, they would have been severely burnt.
I've been given a challenge to set off 5 fireworks. Now, they're bigger than the average firework you'd normally get at home, and so they've got to be set off from these tubes here, and that directs the fireworks straight up into the air. I've been asked to make the fireworks go off one after the other at 5-second intervals. I've just got to secure this last one, and I better recap. So I've got approximately 12 centimetres length of fuse connecting one firework with the other, which will allow me about 5 seconds, and make sure they're all connected right. All I have to do now is just put the last one down the tube.
Everything ready?
Oh, I'm looking forward to seeing this.
Okay, give me the fuse and the tape.
Okay.
Helen has wired these fireworks to be fired electrically. This is safer when setting off large fireworks.
And woo!
If you look carefully at the top of the tubes, called mortars, you can see the flame burning along the fuse.
It's so far so good, yeah? Last one?
They all seem to
You're quite
work.
successful, isn't it? Very good, very good, very good. But don't think for 1 minute you're finished with fireworks, because tomorrow I want you to accompany our display team down to Highclere Castle to help set off a major display. Now this is going to be accompanied by full orchestra, and there's going to be 6,000 people there to see you do it.
And I suppose it's like this, there can be no rehearsals. It's just got to have one go at it.
Absolutely.
Okay, well I'll have a go. I'm at Highclere Castle. The audience don't arrive to see this firework display until this evening, but already they're putting me to work.
As you lay them out, we batten them together. Each rack is fired on its own,
Yes.
so it's fused on its own as well.
Does that mean that they have to be further apart?
That's right, yeah, so the sparks will not ignite any other firework. Just like a little daisy chain, okay? Okay, and then what we do is we just pop them into the mortars, okay?
Wow, look at this. It's very heavy.
So, what we're going to do is connect all these racks, okay? These are all going to be joined together, and they're going to go in the brown sleeve along with this brown fuse. Then
Right.
we're going to put a detonator into the sleeve.
A detonator is an electrical match.
This is the detonator, okay? That's the explosive head there.
Just that tiny thing is going to set
Just
off
get it
all
quick.
these fireworks.
That one small detonator makes all this go, okay? Keep twisting until... There you go.
Sally, hi. I've just been told that I'm going to be pressing some of the buttons for the fireworks. Can you tell me how it all works?
Good luck is the first thing. I have here the full score of music, and I've gone through with the firework company, and we've gone split-second timing. We've written in numbers. Now it is immediate. 2 press. And if you sort of say, oh, help, is it me, it's too late. No messing whatsoever.
Right,
okay.
I've got it. I shall be hearing you later then.
Okay, good luck.
Thanks a lot.
Good luck.
Every year, millions of tyres are dumped or buried at different sites in this country. Sometimes these dumps catch fire. The smoke contains poisonous gases. Tyre fires are difficult to control. This one took weeks to put out. But the fact that tyres burn well can be put to good use. In 1993, Eileen Parks and 25,000 other people living in Wolverhampton started to use electricity from the first British power station, using tyres as a fuel. The tyres are burned through a series of furnaces which destroy all the unwanted gases along with the rubber. At the end, all that's left are valuable products like the steel wire used to reinforce the tyres, but above all, clean air.
The buttons was the easy part. It was when they were going off over my head I was
Like you
worried.
say, that's the easy part. Now we've got the best part of the night. Clear up time.
Oh.
Let's go. Do you want to come and check the site with me? And then we can start dismantling the equipment.
Oh, I suppose so.
You'll have muscles in you tomorrow.
The rest of the my heart is beating for that.
And what Helen doesn't know is that her challenge will be to set up a firework display to be watched by 6,000 people.
So cruel. Hello.
Hi.
Helen, this is Michelle who's going to teach you how we make fireworks.
Michelle,
Hi. Pleased to meet you.
You're going to put me to work, are you?
Yes, I am.
Okay.
The first thing we need to get anything to burn is a fuel. So I've chosen this fuel here. It's fine black powder.
And what's that?
Right then, that's charcoal. Now you're probably not familiar with it in that form, but you'll be more familiar with it in this form here.
Oh, the stuff you get on barbecues.
That's
yes,
it,
huge
as you can
chunks of
see.
it.
All we've done is we've broken that down into little pieces, which gives us that fine black powder. So what I'd like you to do now is to try and light that, please.
Like this?
Yes. We take this over to the fume cupboard over here.
I've never heard of that before. What's a fume cupboard?
It's a safe cupboard where we...
This is Huddersfield in Yorkshire. I'm on at the top of a hillside and I'm absolutely freezing. I've been told I've got to find out about fire, which is just as well because I could do with some warming up, and I'm hoping that they've come I must have jumped a mile. Well, I suppose that was fire, all right.
Quite a surprise, Helen. Yes,
Yes,
quite a surprise. That's right.
It wasn't just an explosion from
No, we thought
nowhere.
we'd surprise you with that. Okay, Helen, let me introduce myself. My name's Barry Cook. I'm the chief chemist here, and this is a site where fireworks are made. Your challenge is to learn about fire, and to begin your challenge, if you'll follow me now down to the laboratory, we can make a start.
Okay.